Let's first understand the MAPS structure. MAPS follows a folder hierarchy based on the supported protocols and standards. Following this are the nodes supported by the specific protocol. Each node directory comprises of profiles, scripts, messages, import and export subfolders. These folder consists of the important components required for the protocol simulation behavior. In the next slide we will explain in detail how each of these components contribute the protocol simulation behavior. Let us now get into details of MAPS scripting. A simple call flow can be achieved using a script with just few straightforward instructions, which is normally the case for conformance test cases. Such scripts are termed as non-event-driven scripts. Non-event-driven scripts are simple scripts with minimum instructions which are executed sequentially. However, to study the complete protocol behavior of an end node, this may not be sufficient. Scripts should be able to handle decision-making, timers, traffic flow, and so on. These scripts are called as event-driven scripts. Event-driven scripts defines flow on basis of user-selected events. Using event-driven scripting one can achieve protocol state machines as per protocol specifications. In an event-driven script, we can observe different type of script as shown here. Message handler. On receipt of any protocol message, the control moves to defined section in the script. Traffic event. On detection of any traffic actions, the control moves to detected traffic event section. Timer. On expiry of any timer, the control moves to respective timer expired section. User events. These events use Godot label or apply event methods to control the user-defined events execution. Let us take an example of call simulation using ISUP protocol with maps on both ends. As seen here, a simple script, with only send and receive commands, can be used to achieve this. Send instruction will send specified message to end node. Receive command instructs maps to receive an incoming message. Prior to sending and receiving the messages, maps establishes a transport layer, over which the messages are exchanged. In ISUP protocol, the messages are exchanged on MTP3 or M3UA transport layer. First the maps on side 1 sends IAM message. Then, the receive command instructs maps on side 2 to receive incoming message. In response to IAM, the ACM and ANM messages are sent back, which are received by maps on side 1 using receive commands. With this, the call is established, and using traffic commands the user can send any traffic. Here, a voice file in a PCM format is transmitted. Again, to release a call, one can use the send command, and receive release complete message from other side using receive command. Here is another non-event-driven example script used for ISDN protocol. Like in the previous example, note the one-to-one correspondence between the messages and the commands, and an initialization section where important parameters such as CRV, channel number, and time slots are defined. Event-driven scripts are complex scripts, where the execution of scripts is driven by events. For every event, there will be section defined, and the execution will be passed to this section accordingly. As shown below, every script in MAPS starts with an initialization section where all the call parameters are initialized. And now, the script waits for any event, based on which the event received, the control jumps to the respective section of the script. For example, on reception of initial address message, the message handler command passes the execution control to the initial address handler section. In the initial address handler section, a send command is executed, which sends out address complete commands to the DUT. At the same time a protocol timer is started. Along with this timer, an user event is enabled, which gives user the option to either answer or terminate the call in the call generation window. If no selection is made during this timer, the timer expires. On any timer expiry, an event is triggered which will take the control to respective timeout section. For example, here the answer call timer is set to 10 seconds. After this timer has expired, the execution is passed to the answer call timer expiry section. In this section the answer message automatically is sent to the DUT and the call is established. This section also defines the traffic to be handled. For example, this script is transmitting a voice as file using txFile command. Once the traffic is transmitted completely, the traffic event is detected, identifies the details, and passes the control to traffic handler section. In the traffic handler section, the actions to be taken is defined. For example, here we have on file sent section, where the status of the call is updated as file sent. Now, the call can be terminated manually by applying the terminate user event from the call generation window. Note that this event was previously enabled in the address complete section. Once the terminate user event is applied, the execution is passed to terminate section, where the release message is sent to the DUT. The script now waits for the release complete as a response message from the DUT. When the release complete is received, the message handler passes the execution to release complete section. The call status is now updated as released, and script execution completes. The MAPS script editor includes various commands grouped as shown: action commands, conditional and flow control commands, variable commands, log commands, and traffic commands. User can use any command in any order from the tree structure to build the required set of instructions. Send command from the action tree is used to add send instruction in the script, which is used to send the message. If, else, and if, wait, and go to commands from the conditional tree are used to add decision-making action instruction. Assign variable command from variable declaration tree is used to add instructions to update call status. Event log command from the comment tree is used to add instructions to log the occurring events. Start timer command from the action tree is used to define the timeout periods within which an expected event has to occur. Here, we are showing you some of the commands and variables that play an important role in displaying call status and events in the call generation window. For example, a key identifier variable updates the call info column in call generation and reception windows. In ISUP, the key identifiers are OPC, DPC, and CIC. Next, the status variable updates the call status column with values such as call initiated, call active, and so on. Similarly, the result variable updates the results column with values such as pass or fail for any executed events. The active user events command updates the user selection menu of the defined events under events column. The event log command updates the script events to event log window. The error log command updates the script errors to error log window.